Hello and welcome to Grace Tutorial. In this video lecture, we will be discussing the third part of the chapter Aldehydes, Ketones and the Carboxylic acid. And here in this part, I will be explaining you about the different methods of the preparation of aldehydes as well as the ketones. So the first method that we have for the preparation of the aldehyde is from acid chloride. So how can we prepare the aldehyde as well as the ketone from the acid chloride? Let's have a look. Well, we know that, acid chloride. What is the formula for acid chloride? RCOCl. Yeah. So RCOCl is basically the formula for the acid chloride. So what happens? You see, when the hydrogen gas is passed through the acid chloride in the presence of the palladium or barium sulfate in boiling xylene, look at here once again, when hydrogen gas is passed through acid chloride, RCOCl is the acid chloride, right? Let me write here. So acid chloride. So when hydrogen gas is passed through acid chloride in the presence of palladium or barium sulfate in boiling xylene, what generally happens? So RC and here H2 is there, so it will be broken and finally it results RCHO plus HCl, and one more H is there, hydrogen is there, that reacts with Cl, that means HCl is formed. So RCHO is aldehyde. In this way, the aldehyde is formed through this method. It's very simple that when hydrogen gas is passed through acid chloride in the presence of palladium or barium sulfate in boiling xylene, then aldehyde results along with hydrochloric acid, that is HCl. Let me give you the specific example for this. Well, if we will place this methyl group in the place of the CH3, then CH3, COCl, H2 gives rise to the same as it is, palladium, barium sulfate and xylene, right? What generally happens? CH3, CHO. This is acetaldehyde. So acetaldehyde results, right? And here the name is acetyl chloride. That means when the acetyl chloride, when the hydrogen gas is passed through acetyl chloride, then here the CH3C and here H will be broken. That means CH3CHO, that is acetaldehyde, along with HCl, that hydrochloric acid, is released. In this way, from the acid chloride, we can easily prepare the aldehyde. That means once again, I just want to highlight you the point. When hydrogen gas is passed through acid chloride in the presence of palladium barium sulfate or the boiling xylene, then aldehyde results along with the liberation of the hydrogen chloride. So the specific example of this one is given. Now we'll look at, how the ketone is formed from this acid chloride. Well, basically I have acid chloride. If you will treat or if you will react this acid chloride with dialkyl cadmium, alkyl, generally, the symbol for alkyl is R. So R2, that means dialkyl. So when acid chloride reacts with dialkyl cadmium, what generally happens in the presence of dry ether? In the presence of dry ether, then ketone is formed. Cadmium chloride. Then ketone is formed along with cadmium chloride. Let me give you the specific example. This is acid chloride. This is acid chloride. And here it is acetone. Sorry, this is ketone. So RCOR means ketone. And this is acid chloride. And this is dialkyl cadmium. And when this dialkyl cadmium reacts with 2 molecules of acid chloride, then the 2 molecules of the ketones are formed with the liberation of the cadmium chloride. Let me give you the specific example. But what will be used here as the agent? Here the dry ether. In the presence of this dry ether, then the ketone is formed. The specific example, if you will place the CH3 here, COCl, acetyl chloride, right, CH3 whole 2 CD. So this is dimethyl cadmium, because methyl group is there, so methyl group, that is CH3 whole 2 is there, that means dimethyl cadmium. And when this dimethyl cadmium reacts with acetyl chloride, what happens? 2 molecules of CH3 COCH3. So what is the name of the CH3 COCH3? Initially in the previous lectures that I had explained you in a very detailed and the systematic manner about the nomenclature of the aldehydes and ketones. So I hope you can easily say that. So the CH3 COCH3 means acetone, right? Acetone, and finally CdCl2, that is cadmium chloride is obtained. So this is what the main product here, the dry ether, is used. So this is the specific example in which how the ketone is formed from the acid chloride. So in this way we have the first method, that is from acid chloride, the how aldehydes are formed, along with the specific example also given for you. Similarly, how the ketones are from the acid chloride, the specific example is also given for you. I hope all of you understood it very well. Now we will move on to the second method, that is by the oxidation of alcohol. So if we look at the method number 2, that we have by the oxidation of alcohol, that means from alcohol that we need to prepare the aldehydes as well as the ketones. Well, alcohol is basically of 3 types. One is RCH2OH, and this alcohol is primary alcohol. And another that we have RRCHOH. This is secondary alcohol. Similarly, if 3 R's are there and COH, this is tertiary alcohol. So in this way we have 3 different types of alcohols: primary alcohol, secondary alcohol and tertiary alcohol. This is the formula for primary alcohol, RCH2OH, and RR, that means 2 alkyl groups are there, right? So this is the formula for secondary alcohol, and this is the formula for tertiary alcohol, wherein the 3 alkyl groups are there. Now we need to prepare the aldehyde from primary alcohol. That means when primary alcohol gets oxidized, let me write for you. When the primary alcohol, that means RCH2OH, this is primary alcohol, right? When the primary alcohol gets oxidized in the presence of potassium dichromate, that is K2Cr2O7 or KMnO4, or we also can use sulfuric acid. So these are the various agents which can be used for the formation of the aldehyde from this. That means when the primary alcohol gets oxidized in the presence of these agents like the potassium dichromate, potassium permanganate or the sulfuric acid, then it gives aldehyde, RCHO, with the liberation of the water molecule. So this is aldehyde, and this is primary alcohol. Yeah, it's very simple to understand, my dear students. Here what happened, the hydrogen atom will be broken here by the oxidation, with the oxidation. So hydrogen here, it will be broken, and RCHO, that means RCHO, aldehyde is formed, and one more 2 hydrogens are there along with oxygen, that is water. So in this way the aldehyde is formed from here in this method. Let me give you the specific example so that you can understand it very clearly. The specific example is nothing but if you will place the methyl group in place of this R, everything will be remain same, that is CH3 CH2OH. So CH3 CH2OH, what is the name of this one? Ethyl alcohol. Look at here, this is CH3 CH2, this is ethyl and OH, alcohol, ethyl alcohol, or according to IUPAC name, this is since the 2 carbon atoms are there, that's why we can say ethanol. That means alcohol is there, right? So the suffix of alcohol is -ol, right? So ethanol, or in the in common name, that is ethyl alcohol. Ethyl alcohol, when it is oxidized in the presence of the same, So what happens? CH3 CHO, that is acetaldehyde results with water molecule. So acetaldehyde. So you need to remember that how the aldehyde is prepared from, the primary alcohol, or how the aldehyde is prepared from the alcohol means you need to say that when the primary alcohol gets oxidized in the presence of the oxidizing agents like potassium dichromate, potassium permanganate, sulfuric acid, then aldehyde results with water molecule. And you can also give the specific example related to that. So this is what the product, that is acetaldehyde, is obtained with water molecule. Well, in this way, the aldehyde is prepared from, by the oxidation of alcohol. But which alcohol? Primary alcohol. So now there may be a doubt that how the ketone is formed. Yes, the ketone is formed by the secondary alcohol. That means how the aldehyde is formed from, by the oxidation of the primary alcohol. Similarly, ketone is obtained by the oxidation of the secondary alcohol. So I have written here, this is the secondary alcohol. So RrCHOH, this is secondary alcohol. When the secondary alcohol gets oxidized in the presence of the same as it is, that is potassium dichromate or potassium permanganate or sulfuric acid, right? This is a secondary alcohol. Yeah. So secondary alcohol, when on oxidation of the secondary alcohol, it generally forms RrC double bond O. That means this is ketone along with water molecule. So what is the specific example? CH3 CHOH, and here it is oxidation takes place with the same as it is, right? CH3 C double bond O H2O. So what is the name of this compound? The name of this compound is acetone. Yeah, and here it is isopropyl alcohol. The name of this one is isopropyl alcohol. So look at here, when the secondary alcohol gets oxidized, then ketone is obtained with water molecule. So the specific example, when isopropyl alcohol, right, if I will place the CH3 in the place of these are 2 R's, then CH3 and CH3 and CHOH, right, oxygen, along with, finally what it gives, acetone produces along with the water molecule. That means it is very simple to understand by this method. The aldehydes and ketones are formed by the oxidation of alcohol. But when the primary alcohol gets oxidized, aldehyde results, and when the secondary alcohol gets oxidized, the ketone results. I have also written the specific examples for you along with the names, and I hope the second method is also very clear for you. Now it's better that we move on to the next method, that is by the catalytic dehydrogenation of alcohol. Well, if you look at the catalytic dehydrogenation of alcohol, but before that we need to understand the term dehydrogenation. So dehydrogenation, so what is the meaning of the hydrogenation, so that we can understand the dehydrogenation? So hydrogenation means the addition of hydrogen. So when the hydrogen is added, then the process is called the hydrogenation. At the same time, when the hydrogenation is removed, then that is called dehydrogenation. That means removal of hydrogen from something, from some substances, that is called the dehydrogenation. So by the catalytic dehydrogenation of alcohol, that means the dehydrogenation takes place, but the dehydrogenation of alcohol, how? By catalytic. That means using a catalyst, the dehydrogenation generally takes place. And by this method that we need to prepare the aldehydes as well as the ketones. But now the question is, alcohol means, I have said you here initially that there are 3 types of alcohols: primary alcohol where 1 alkyl group is there, secondary alcohol where 2 alkyl groups, similarly the tertiary alcohol where 3 alkyl groups are there, right? So the same way, if we, if the primary alcohol, that is RCHO, if the primary, the primary alcohol, RCH2OH, right? This is the primary alcohol. So the primary alcohol is, when it is heated at copper and 300 degrees centigrade. That means what happened? This hydrogen atom, this hydrogen molecule will be removed. So what is obtained here? RCHO, aldehyde. So this reaction is very simple to understand. When primary alcohol is heated with the copper at 300 degrees centigrade, the aldehyde results with hydrogen. That since the hydrogen is removed from here, that's why the name, process of the name is given here, dehydrogenation of alcohol. That means here the alcohol is there, and from this alcohol the hydrogen is removed. Since the hydrogen is removed from this alcohol, that's why this is called dehydrogenation of alcohol. So if the primary alcohol gets dehydrogenated with the copper at 300 degrees centigrade, what generally happens? Aldehyde results. Let me give you the specific example. This is primary alcohol. So the specific example is CH3, CH2, OH. This is ethyl alcohol. Ethyl alcohol. (300 degrees centigrade), heated. Generally what happens are CH3, CHO, and with hydrogen. This is acetaldehyde. Acetaldehyde results. So when the ethyl alcohol gets heated with copper at 300 degrees centigrade, then acetaldehyde results with the removal of the hydrogen. So this is the specific example. Now how the ketone is obtained from the catalytic dehydrogenation of the alcohol? We will take for ketone, for the formation of ketone, we will take the secondary alcohol. When the secondary alcohol is heated with copper at 300 degrees centigrade, then what generally happens? Ketone is formed with the removal of the hydrogen molecule. So this is ketone, and this is secondary alcohol. Let me give you the specific example for you. If I place here CH3, CH3, CHOH, isopropyl alcohol, and when it is heated with copper at 300 degrees centigrade, then what generally happens? This hydrogen, the hydrogen is removed. That means CH3, CH3, C double bond O, hydrogen. So this is acetone. So it's very simple to understand, my dear students. When the primary alcohol gets heated with copper at 300 degrees centigrade, aldehyde results. Specific example is given for that. Similarly, when the secondary alcohol gets heated with copper at 300 degrees centigrade, then ketone results with the removal of the hydrogen molecule. The specific example, this is isopropyl alcohol, and here in this way the acetone is obtained. So if there is a question, suppose if the question comes in the examination that how the aldehydes and ketones are formed by the catalytic dehydrogenation of the alcohol, that you need to remember these methods. You need to remember the processes, how the aldehydes and ketones are formed from this method, so that it will be very much helpful for your examination purpose. Well, this is all about the third method. Now we will move on to the fourth number method for the preparation of aldehydes and ketones. Well, if you look at this method by dry distillation of calcium salt of carboxylic acid. Well, here let us take a mixture of calcium salt of carboxylic acid, RCOO, RCOO. This is the calcium salt of carboxylic acid with we'll take you see HCOO, HCOO, and it is calcium formate. So this is calcium salt of carboxylic acid. Here it is calcium formate. Yeah, when it is heated or distillation takes place. That means when a mixture of calcium salt of carboxylic acid with the calcium salt of carboxylic acid and calcium formate gets heated, then what generally happens? Then aldehyde results. But two molecules of aldehydes results along with 2CaCl, 2CaCO3, calcium carbonate. But we need to understand that how, you see, the CaCO3, calcium carbonate, is obtained. Look at here. Here the calcium carbonate is removed from here, CaCO3, and from here as well, the calcium carbonate is removed from here, that is CaCO3. So 2CaCO3, calcium carbonate, and next we have RR, that is 2R, right? And 2C, 1C here and 1C here, that is 2C. Similarly 2 hydrogen, right? This is 2 hydrogens, and oxygen, from one oxygen from here and another oxygen from here. In this way, the 2 molecules of aldehydes are obtained when the calcium salt of carboxylic acid reacts with calcium formate. Let me give you the specific example for that. If I will take CH3 COO, CH3 COO, Ca, this is calcium acetate. What's the name of this compound? Calcium acetate. Along with, HCOO, this is calcium formate. So what generally happens? The calcium carbonate is removed from here. That means this calcium carbonate, and here also this calcium carbonate is removed from here. So when the distillation takes place, then 2CH3 CHO, that is acetaldehyde, results with 2CaCO3. Yeah, 2 molecules of acetaldehyde along with 2CaCO3 results. And how it is formed, that's what I have shown here. But you see, sometimes when the calcium acetate individually gets heated, that's what we need to understand. Suppose the calcium acetate, CH3COO, CH3COO, calcium acetate. When the calcium acetate is individually heated, then what happens? The calcium carbonate results, no doubt. But here what is there remained? CH3CO, CH3. CH3, this is CO. So acetone results. So we need to remember here, calcium acetate. Well, when calcium acetate is heated only individually, then acetone forms. That means ketone, the member of the ketone, is obtained. Similarly, when calcium formate individually heated, what happens? HCOO, calcium, right? If it is heated, then it's very simple, the calcium carbonate is removed from here. So if the calcium carbonate is removed, then what is there? HCHO. So HCHO, that means formaldehyde is obtained. A calcium carbonate, right? So let me explain you in a very detailed manner, because this is one of the most relevant point from the methods of the preparation of aldehydes and ketones, which often comes every year in the examination. That you see how the aldehydes and ketones are formed by the dry distillation of the calcium salt of carboxylic acid. The point is that when a mixture of calcium salt of carboxylic acid and the calcium formate gets heated, then the 2 molecules of the aldehyde results. But if we will take the specific example, if we will place the methyl group in the place of this R, that is CH3COO, CH3COO, here it is calcium, then calcium acetate, that means when a mixture of calcium acetate and the calcium formate are heated, then the 2 molecules of the acetaldehyde results. That means if both the mixtures are heated, then acetaldehyde results. But when the calcium acetate is individually heated, then what happens? Here the acetone only results. That's the point that we need to remember. That means how the ketone is obtained from here, only when the calcium salt of carboxylic acid is heated, then the ketone will be formed. And with the specific example that I have shown here, the calcium acetate on heating, that it gives acetone. Similarly, if the calcium formate individually heated, then it gives formaldehyde. So if calcium formate individually heated, it gives formaldehyde. If calcium acetate individually heated, it gives acetone. But if calcium acetate and calcium formate both heat in the mixture with both the mixture will be heated, then what happens? An acetaldehyde results. So this is what you need to remember from this method, for the preparation of the aldehydes as well as the ketones, that is by dry distillation of calcium salt of carboxylic acids. Well, and this is what's all about the 4th method for the preparation of the aldehydes and ketones. And now we will discuss the 5th method of the preparation of aldehydes and ketones.